Breakdown of logistic regression, starting from the basics and including a real-world example. What is logistic regression? It's a supervised machine learning algorithm used for classification problems. It predicts the probability of a categorical outcome, usually binary, like yes or no, based on a set of independent variables. It's often used for tasks like predicting whether a customer will make a purchase, determining if an email is spam or not, assessing the risk of a patient developing a disease. Key steps. 1. Collect data. Gather a dataset with examples of both outcomes, e.g., customers who purchased and those who didn't. 2. Define variables. Identify the independent variables, features, you'll use to make predictions, e.g., customer age, purchase history, website visits. 3. Create a logistic function. This S-shaped curve, sigmoid function, maps any real-valued input to a value between 0 and 1, representing probability. 4. Train the model. Use an algorithm to learn the relationship between the variables and adjust the function's parameters to best fit the data. 5. Make predictions. For new data points, plug their values into the trained model to get a probability of the outcome. 6. Interpret results. Use the probabilities to make decisions or classify data points, e.g., predicting a customer is likely to buy if their probability is over 0.7. Real-world example. Predicting email spam. Variables. Independent. Words in the email, sender's email address, time of day sent. Dependent. Outcome. Spam or not spam. Training. The model learns which words and patterns are associated with spam emails. Prediction. A new email is inputted, and the model calculates its probability of being spam. Interpretation. If the probability is high, the email is likely flagged as spam. Differences between linear and logistic regression. Feature. Linear regression, logistic regression. Dependent variable. Continuous, e.g., price, height. Categorical, e.g., yes, no. Spam, not spam. Output. Predicts a continuous value. Predicts a probability. Assumptions. Linear relationship between variables. No assumption of linearity. Decision boundary. Straight line. S-shaped curve, sigmoid. Use cases. Predicting numerical values. Classifying data points. Remember, logistic regression is a powerful tool for classification tasks. Understanding its steps and key concepts is essential for effective use. Visualizing the S-shaped curve and decision boundary aids comprehension.